Okay, I hope I'm audible to all students who are attending this lecture for the Delhi School of Economics, MA Economics entrance. We intend to start with the discussion of the Delhi School of Economics 2021 paper for the MA Economics entrance. Okay, so let's quickly look at the first question which has come in the entrance. Consider the problem of maximizing f of xy equal to x square plus 2xy plus by square with respect to xy and subject to the constraint x plus y equal to 100, where b is a parameter taking some fixed value greater than 1. And we are given that let v as a function of b be the minimum value attained as a function of b. So v as a function of b is the minimum value attained for this particular function f of xy subject to this constraint x plus y equal to 100. And v dash b is the first order derivative of v of b. The question is asking us which of the following options are correct. Is v dash b strictly positive? Is v dash b strictly negative? Is v dash b equal to 0? Or does the sign of v dash b change with b? So let me come to the whiteboard and let's quickly solve this particular problem. Okay. So we are starting with our discussion of the Delhi School of Economics 2021 paper for the MA Economics entrance. And we are looking at question number 1. So quickly writing what is given to us. We are given that the problem is maximizing f of xy equal to x square plus 2xy plus y plus by square subject to the constraint x plus y equal to 100. And we are given that b is strictly greater than 1. The parameter b takes the value strictly greater than 1. Okay. Now, let's quickly do this optimization and let's find the values of x and y which we get. Okay. So objective is to maximize f of xy. Okay. So first of all, let us see, guys, how I can create the constraint here. One method is to use the Lagrangian, but instead of using the Lagrangian, what we can do is I can create x plus y equal to 100 here. So I can write it like this. Consider f of xy equals x square plus 2xy plus by square. This is given to us. Now I can use the identity x square plus y square plus 2xy is x plus y whole square. So see what I am doing. This by square I can write as the sum of y square. Okay. And since I am adding y square, I need to subtract y square. Okay. Or what I can do is that I'm adding y square. So yeah, I need to subtract y square also, and then I add by square, which is the term given to us. So see what I have done. To this particular term, I have added y square and subtracted y square. Now, from here till here, x square plus 2xy plus y square, I can call it as x plus y whole square. Remember the identity a plus b whole square, a square plus b square plus 2ab. And this I can write as within this and this, I can take y square common. So I get b minus 1 times y square. So I get my f of xy as x plus y whole square plus b minus 1 times y square. Now, what is x plus y equal to? It's equal to 100. So I can use it now. So I can write that my f of xy will be x plus y is nothing but 100 plus b minus 1 times y square. And I can call this as the function g of y because it's in terms of y only. So see, guys, what I have done. I'm revising the steps again till here. We were given the function f of xy. We need to maximize this subject to x plus y equal to 100. One method is you use the Lagrangian. Even that is going to give you the results. But the easier method is somewhat I should do something to create x plus y term here in the objective function. Because we are given the constraint that x plus y should be equal to 100. So what the trick we have used is We were given f of xy, we add y square and we subtract y square. Now x square plus 2xy plus y square, I can write x plus y whole square plus b minus 1 y square, because within this I take y square common, I get b minus 1 inside. X plus y is 100, so 100 square plus b minus 1 times y square. This is purely in terms of y, so I can call it as the function g of y. Now the first order condition for maxima, g dash y equal to 0, which implies if I differentiate with respect to y, what do I get? B minus 1 times 2y equal to 0. Now what else are we given? We are given that b should be strictly greater than 1. So since b is strictly greater than 1, b minus 1 into 2y equal to 0 implies y must be equal to 0. B cannot be equal to 1 because we are given that b is strictly greater than 1. That means for the whole term to be equal to 0, y should be equal to 0. And when, so this is my answer, y star is 0. So what will x star be, guys? X star will be 100, because x plus y should exactly be equal to 100. So we have got y star as 0 and we have got x star as 100. Okay, so hoping all students have understood this. And you can even do the double derivative to check that you have a maxima. So if you do the double derivative, g double dash y, what will g double dash y be? If I differentiate this again with respect to y, what do I get? I get 2 times b minus 1, which is strictly positive. So I can write that therefore g of y is maximum at y star equal to 0. Therefore, I can write, therefore, x star is equal to 100. Since x plus y should be equal to 100. So I can say that my function f of xy is maximum at x star equal to 100 and y star equal to 0. Now, what else was given to us? We were given that what is v of b? V of b is the, please make this correction, v of b is the maximum value attained. We can make a correction here also. Or there's one correction I would want to make here, that if you look at the objective, the objective was to minimize, guys. Please make this correction. Objective was to minimize f of xy. Because you are seeing that the double derivative g double dash y is greater than 0. So I can say convex. Convex means you have a minima. So please make this correction, all students who are attending this lecture. I can write g of y is minimum at y star equal to 0 and x star equal to 100. So I hope all students attending this lecture have made this correction. The correction I'm repeating again, objective is to minimize f of xy, not maximize. That is first thing. And second thing is the function f of xy is minimum at, you can clearly see y star equal to 0 and x star equal to 100. Okay, so now what else was given to us? We were given that v of b, if you look at the function v of b, so v of b is the minimum value attained as a function of b. So now what is v of b? So please make this correction. This is minimize, okay? And if you talk about v of b, what is v of b? Put the values of x and y which we have got from the optimization. Let's put the values of x and y which we have got from the optimization. So if we put the values of x and y, so I get v of b as the function f of xy, but evaluated at x star comma y star. So f of xy is x square plus 2xy plus by square. I put the optimum values of x and y. X is 100, so 100 square plus 2 times 100 times y is 0 plus b times 0 square. So this is going to be 10,000. So my v of b is 10,000. Okay. So what is my v dash b? Objective was to find out v dash b, right? So V dash B is equal to 0, because if my V of B is 10,000, which is a constant, V of B is 10,000, which is a constant, so its derivative V dash B will be equal to 0, because all of us know that derivative of a constant is 0. Derivative of a constant is 0. So hoping all students have understood this. Okay, so first of all, the objective was to do the optimization of the function f of xy subject to the given constraint. We had done the optimization and we had found out that the optimum values were x star equal to 100 and y star equal to 0. Now at these optimum values, we had also found out the function v of b. Okay, we had found out the function v of b at these optimum values, and it was coming out as 10,000, because when I put x star and y star in this, I get 10,000. If I differentiate, what do I get? If I differentiate, I simply get the answer as 0. That means my v dash b is simply coming out as 0. So I can now come back to the question paper and we can mark the correct answer. The correct answer for this question is v dash b is equal to 0. Okay, this is the correct answer for this particular question. So hoping all students attending this lecture have understood question number 1 and have no doubts. Okay, let me make a correction here also, guys, that the original problem was to maximize only. If you look at the original problem was to maximize the function only. Okay, but v of b was the minimum value attained as a function of b. So we have seen that the minimum value of the function is attained at x star equal to 100 and y star equal to 0. So let me come to the whiteboard and let me make a clarification here. The objective was to maximize only. Initially, the objective was to maximize the function only. But v of b is what? V of b is the minimum value of f of xy. And through the second order derivative, we have shown that f of xy will attain the minimum value at x star equal to 100 and y star equal to 0. So if you talk about the question is maximize f of xy, but v of b is the minimum value attained. That is what was given to us in the question. If I come back to the question, v of b is the minimum value attained as a function of b. Okay, so once you put x star as 100 and y star as 0 in the function f of xy, you obtain the minimum value of f of xy, which we call as v of b. And that came out as 10,000. If you differentiate it, you get 0. Your answer is 0. Okay, so let's look at question number 2 now. Consider any real value continuous function f defined on the set of all real numbers satisfying f of x is equal to x for all x belonging to real numbers. If f is not the identity function, then which of the following is true? Okay, so we are given that f is a continuous function. The domain is nothing but set of all real numbers. Okay, and it satisfies that f of x, which is my composite function, is giving me back x itself for all x belonging to real numbers. If f is not the identity function, that means f is not the identity function means what? It means that f of x is not equal to x. Because f of x equal to x is called the identity function. So f of x is not equal to x. Which of the following statement is true? Is f a constant function? Is f strictly decreasing? Is f strictly increasing? No function other than the identity function can satisfy this property. Okay, so let's quickly come to the whiteboard and let's solve this particular question. So we are now looking at question number 2. So quickly writing what is given to us. We are given that any real valued function, continuous function, F defined on the set of all real numbers satisfying f of x is equal to x for all x belonging to real numbers. And we are given that f is not an identity function. We are given that f is not an identity function. That is, we are given that f of x is not equal to x. Now we need to find out what kind of a function is f of x. So first of all, let's start with the equation which is given to us. So consider f of x equal to x. Now guys, in order to look at what kind of function f of x can be other than the identity function, let's first differentiate this and check out the first order derivative. So I can write differentiating the above equation with respect to x. What do I get? F dash of f of x into f of x ka derivative is f dash x equal to x ka derivative is 1. I hope all students know how to differentiate this, right? F of x ka derivative is f dash of f of x into internally f of x ka derivative is f dash x equal to x ka derivative is 1. Now you can clearly see that this is a differential equation. And what is the, now if you look at this particular differential equation, this is a differential equation, right? Now what can be the possible solution to this particular differential equation? Now if you put f of x as x, does it satisfy this? So let's check. F dash x is equal to 1. Okay, and f dash of f of x itself is equal to x only, and we have shown that f dash x is equal to 1. So guys, I can write f dash of f of x. So I can maybe write it more properly like this, that f dash of f of x is how much? X only, and f dash x is equal to 1. So this is also 1, this is also 1, and 1 into 1 is 1. So f of x equal to x satisfies, but in the question we were given that f should not be an identity function. So I can say therefore f of x cannot be equal to x, since in the question we are given that f should not be an identity function. Now let us check the same thing, but with f of x equal to minus x. Suppose I take minus x. Is it satisfying this differential equation? Let's quickly calculate f dash x. F dash x is how much? Minus 1. If I differentiate with respect to x. And then what is f dash of f of x? Now, first of all, what is f of x, guys? F of x is minus x, right? And what is f dash? You can clearly see that f dash of x is minus 1. You can clearly see that. So if you find out f dash of minus x, that is also equal to minus 1. Okay, f of x is equal to minus x, right? So my f dash x is equal to minus 1. So if I have to find out f dash of f of x, it will be f dash of minus x, okay, which will be equal to minus 1 only. So you can clearly see product of minus 1 with minus 1 is also equal to 1. Product of minus 1, because f dash of f of x has also come out as minus 1, multiplied by f dash x is also minus 1. So minus 1 into minus 1 is also 1. So I can say that f of x equal to minus x also satisfies the differential equation. You can clearly see that f of x equal to x also satisfies this differential equation. F of x equal to minus x also satisfies this differential equation. And you can clearly see that both these functions have domain which is set of all real numbers. So you can clearly see that this is my answer. F of x is equal to minus x. And now if you look at because f of x equal to x cannot be the answer because f should not be an identity function. So f of x must be equal to minus x. And you can see that f of x equal to minus x is satisfying because f dash x is -1 and f dash of f of x, it's a composite function, guys. So f dash of f of x will be f dash of minus x because f of x is equal to minus x. And if you differentiate minus x, what do you get? You get -1 only. What is the derivative of minus x? The derivative of minus x is -1, right? So hoping all students have understood this, that my answer is f of x equal to minus x. Now, if I come back to the problem, so is f a constant function? No, because I've got my answer as f of x equal to minus x. Is it a strictly decreasing function? Yes. F dash x is equal to -1, which is less than 0. Therefore, I can say that f is strictly decreasing. We have got the correct answer. The correct answer for this question is option B. This is the correct answer. You can clearly see that the function is strictly decreasing. I have not taken f of x equal to x because in the question we were given that f is not the identity function. If f of x cannot be equal to x and it should satisfy this, it means f of x is coming out as minus x. And if you differentiate it, you get -1, which is strictly less than 0. So it's a strictly decreasing function. Okay. And then I intend to look at the last question for this particular lecture, after which we are going to stop. This is question number 3. Okay, so let's quickly look at question number 3. Consider a real valued function f that satisfies f dash x is equal to f of x car squared for all x in some domain of real numbers, and it also satisfies that f of 2 is equal to 2. We need to find out f of -2. Okay, so let me come to the whiteboard and let's solve for this particular question, erasing this part off. Quickly writing what is given to us. So in question number 3, we are given that a real valued function f satisfies f dash x is equal to f of x car squared. Okay, for all x belonging to real numbers. And we are also given that f of 2 is equal to 2. What do we need to find out? We need to find out f of -2. Okay, so first of all, guys, we need to think of a function which satisfies this property. F dash x should be equal to f of x car square. Now, what possible function you can think of whose square gives you f dash x? Okay, so if you give it a thought, you can see that if I take a reciprocal function, suppose I take f of x is equal to 1 by x. Suppose I take this as my function. Then what is f dash x? If you differentiate, you get -1 by x square. And clearly you can observe that f dash x is nothing but f of x car square. F dash x is nothing but f of x car square. Okay, so hoping students have understood how we have got this. If you look at the function f of x, it is 1 by x, right? And if you look at f dash x, it's -1 by x square. You can clearly see that it's satisfying the property that f dash x is equal to f of x car square. Okay, so I hope all students are clear till here. Then if we quickly go to further solve, now you can clearly see we are now going to get a differential equation. Okay, one more thing I want to clear, f of x should be equal to -1 by x. Because if I take f of x as -1 by x, then only you can see that f dash x will be equal to 1 upon x square. Now it's going to be 1 upon x square, and you can clearly see that f dash x is equal to f of x cos square. F dash x is equal to 1 upon x square, since you can clearly see that 1 upon x square is minus 1 by x cos square. So I can write, therefore, my f of x, which I can call as y, is equal to minus 1 by x. Okay, so now we have now somewhat got the different. What is our differential equation, guys? This is our differential equation. So our f dash x is equal to 1 upon x square. Okay, so this implies, what is f dash x, guys? Dy by dx. This is equal to 1 upon x square. This is my differential equation. We know how to solve the differential equation using method of separation, method of separating the variables. So I erase this part off. I erase this part off, and let's quickly solve this. So I can write that, therefore, I can write, if I further solve, this becomes dy by dx is equal to, so our dy by dx was coming out as how much? Okay, so our dy by dx has come out as how much? F of x is nothing but y, guys. So I can write y cos square. Okay, forget about this. You can clearly see that if you look at this, f dash x is equal to f of x cos square, right? Let's start again. Let's start properly. F dash x is nothing but dy by dx. F of x is nothing but y cos square. So I can write that dy by y square is equal to dx. Okay, I am using the method of separating the variables to solve for the differential equation. Integrating both sides, what do I get? Integral dy by y square is equal to integral dx. This is integral y to the power minus 2 times dy is equal to integral dx, which implies y to the power minus 2 ka integral is y to the power minus 2 plus 1 upon minus 2 plus 1. Integral of dx is nothing but x plus the constant c of integration. I can write in the bracket where c is a constant of integration. Where c is the constant of integration. So what do I get now? If I erase the initial part off, so I can write that this implies minus 1 by y is equal to x plus c, which implies, what do I get? I get y is equal to minus y is equal to 1 upon x plus c. This is what I get. Or I can write it like this, y is equal to minus 1 upon x plus c. Now guys, we are given that f of 2 is equal to 2. So if I put the values of x and y as 2, what do I get? So if I erase this particular part, so putting x equal to 2 and y equal to 2 in the above equation, 2 is equal to minus 1 upon 2 plus c, which implies 2 into 2 plus c is equal to minus 1, which implies 4 plus 2c is equal to minus 1, which implies 2c is equal to minus how much? I think we have made some mistake somewhere. Let me just check up the mistake. Okay. So if I solve for a C now, so this is 2C equals -1 minus 4, which implies C is equal to -5/2. Okay. So we are getting C as -5/2. Now, if I put the value of C in the function, what was the function? This was the function. So I can write, therefore, y is equal to -1 upon x, and C is -5/2. This is -1 upon, I can take 2 as the LCM. So this is 2x minus 5. So 2 goes up, it becomes -2 upon 2x minus 5. This is my function f of x, -2 upon 2x minus 5. Okay, now we need to find out f of -2, right? That was our objective, to find out f of -2. Okay, so what will f of -2 be? F of -2 will be -2 upon 2 times -2 minus 5, which is -2 upon -4 minus 5, which is -2 upon -9, which is 2/9. So the final answer for this question is 2/9. Okay, so the objective was to start with the equation which is given to us, that f dash x is equal to f of x cos square. F dash x we have written as dy by dx. F of x is nothing but y. We solve the differential equation dy by dx equal to y square using method of separating the variables. Once we solve for the differential equation, okay, we get the answer as y equals -1 upon x plus c. Okay, then we use the information given to us that f of 2 is equal to 2. That means if I put y as 2 and x as 2 and I solve for c, I get c as -5/2. I put back the value of c as -5/2 in the expression for f of x. I get f of x as -2 upon 2x minus 5, and I put the value of x as -2 because we need to find out f of -2. I get f of -2 as 2/9. So if I come back to the question paper, so for question 3, there is some problem with the parts given to us because the answer to this question is 2/9. Okay, so you can write that question 3, there is some error, because if you look at the options given to you, none of the options is containing the correct answer. So we can say that the options are misspecified. It's perfectly possible in the entrance for some of the options to be misspecified, or there might be some printing error in writing the correct options. The correct answer for this question is 2/9. Okay, it was a very easy question. Okay, I'm again revising this again. F dash x is nothing but dy by dx. F of x is nothing but y ka square. You integrate both sides. So this is dy by y square equal to dx. Just integrate both sides. So dy by y square ka integration is y to the power -2 ka integration, which is y to the power -2 plus 1 upon -2 plus 1. X ka integration, dx ka integration is x. So you get -1 by y equal to x plus c. And when you solve this, guys, you get the answer as 2/9 when you calculate f of -2. So clearly there is some problem with the options. None of the options is correct. Answer is 2/9. Okay, so this is where I intend to stop in this particular lecture. The objective was to discuss the first 3 questions which have come up in the Delhi School of Economics 2021 MA Economics entrance paper. I will be starting with my discussion from question 4 onwards in the next lecture. So I hope all students have enjoyed this lecture. Any doubt, you can unmute your mic and ask, or you can call up, or you can mail me your doubts at divineschoolofeconomics@gmail.com. This is where I stop in this lecture.